I know we can do better than that. We have guests. Let's know what Mass Pride is all about. Good morning. Thank you very much. This is a very unique opportunity for our school. We are going to hear about something that is of concern to all of us, which is climate change, in particular here in South Florida, sea level rise. You will hear from a lot of people today, including your peers, who have gathered today to introduce you to, educate about, and hopefully gain your involvement in this most serious of problems. It's not going away. It's going to happen with greater frequency as you get older, and it will impact everything that we've come to love about South Florida. Now, we are always good stewards, and we are good participants. It means that we act respectfully, we listen carefully, and we react when asked. We will have more of these opportunities because of our partnership with this wonderful university, and most recently the partnership that we have found with the School of Journalism and Mass Communication. And it's kind of an interesting thought when you think about it. Why are journalists involved in sea level rise? Well, like you, they're very interested, and they want to get the word out. And who does it better than journalists? About explaining what's happening and what can be done. And you'll hear about what can be done, what you can do personally, and what we can do collectively as a community, as a school, and as a nation. Now, we are going social today. We are going to be streaming this opportunity live so that everything that's seen and heard today will be available to all of South Florida and beyond. In addition, we'll be on social media. I'm happy to say, reluctantly, that I'm now a social media person, much to my chagrin. I'm there now. I'm part of the tweet universe. You can follow us at MAST, FIU, BBC. And to the date, right now, I have all of one follower. So with your devices in hand, please, if you have a phone, make sure it's on silent. Please take part in this activity because it is a social activity. We want you to get the word out about what's happening not only here, but what's happening in South Florida. So take advantage of the digital technology you have available. We have wonderful friends who are helping us. We have representatives from CLEO, Climate Leadership, Engagement Opportunity, as well as science partners, as well as partners from the School of Journalism, who you will meet throughout today. A unique group of students from this collection will also be involved in the October 9th event, which is the King Tide, and you'll learn what that means and represents here this morning. So I'm very proud of the fact that we've been invited to participate. I'm very proud that you're here, and I know that you'll act responsibly and socially as the information unfolds. So I think we're going to begin here momentarily. Am I right, Dr. Gucci? So I will turn the microphone over to you.
Good morning. My name is Raul Reyes. I'm the Dean of the School of Journalism and Mass Communication. If you guys don't know what a Dean does, I'm kind of the principal for the School of Journalism and Mass Communication. We have 2,000 students here on this campus, mostly on this campus, and wonderful faculty members. Some of them are here today. So welcome to this event. It's my pleasure to open this event today and be here and talk to you a little bit before I introduce the people who are going to run the event. First of all, I would like to thank you for being here and your participation. As Principal Welker said, this is an extremely important issue. How many people have heard about sea level rise? A lot of you. And I think as Principal Welker said, This is one of the most pressing issues of our time. And if you are wondering, as he said, about the School of Journalism and Mass Communications involvement, one of the reasons why we are doing this, we see ourselves as a solution center for South Florida. So this is one of the biggest, most important issues. And a lot of this has to do with communication, finding the right message, motivating people like we are doing with you guys today, getting you involved, getting the word out that this is an issue that needs to be dealt with. Your organizers put together an amazing panel of speakers today, throughout the day. They'll be preparing you for the October 9th event, if you haven't heard about. It's called King Tide Day, and it's the highest tide in Miami Beach. And if you lived in Miami Beach before, you live in Miami Beach now, or for anybody who lives in South Florida, you know that periodically Miami Beach gets inundated. You may have seen the pictures, people canoeing down Alton Road. If you've been to Miami Beach recently, you saw all the construction going on. Has anybody seen the construction going on Alton Road and the fact that they closed the road? Some of the issues they are dealing with have to do with flooding and putting up pumps. So they tell us that Miami Beach is not going to get flooded this time. We are hoping that is the case, but we are very much preparing for being on the ground, being there on October 9th, the highest tide, and seeing what's going on. So I would like to thank the professors who put together this event, Professor Ted Gucci, Juliet Pinto, Susan Jacobson, Kate McMillan. I don't know if Kate is here. She'll be here later today. But part of this event is the grant that this professors got last year from the Online News Association to study the impact of sea level rise and how we can communicate to the public about sea level rise in a way that is effective and helps to solve the problem. So I hope you have a lot of fun today preparing for this event. This event will get you out there in the community doing this amazing job that you'll be doing. You'll be trained today to do. It's amazing to see all of you involved in this. I wish you the best. I wish you an amazing program today. And I would like to call Professor Gucci to initiate the program.
Great, thank you, Dean Race. Thank you so much. First of all, I just wanted to say, for the people who are live streaming or who are watching the live streaming event, there are 190 high school students here from MAST at FIU BBC. Do you guys want to make some noise so they can hear you? One of the Okay, now you can stop making noise. So one of the main purposes of this grant was really to do something like this, right? To get college students, to get the universities, to get the high schools together to talk not only about issues of sea level rise, but how to communicate it in an effective, scientific, accurate manner. And it's really that interaction between college students and high school students that excites me the most. So I'm so excited that everybody is here. I want to thank a couple people before we go forward. I want to thank the School of Journalism Mass Communications graduate student organization, PRSSA. They helped sponsor this event and got us this room and do some really fabulous things. I'd like to thank, again, the students from MAST at FIU. Thank you. All right. I'd like to thank the Clio Institute, and you'll be hearing from Caroline Lewis, the founder and executive director of that. And she will be working, and her staff will be working with some students later this morning to prepare for the October 9th event. I'd like to thank Hackers and Code for Miami. One of our... Yay! And as Dr. Jacobson, who's part of the School of Journalism, will tell you about an app that y'all can be participating in, they've been very vital. The tech community in Miami has been vital to trying to create tools for y'all to be using to understand sea level rise. I'd like to thank the South Florida Water Management District. They've been providing us with a lot of great public data. And data, everybody's heard of big data. We all have data in our phones and in our photos and stuff. They are helping us understand what that data is and integrate it into technology again so that we can use it. And Dr. Jacobson will talk about that in a few minutes. I'd like to thank Alta Systems. One of the things that we'll be doing on the 9th, and we'll talk about this here again in a few minutes, is we're going to be sending, Alta is a company that works with FIU, and they're going to be sending balloons high into the air to get high-resolution images of Miami Beach so that we can see the effects of that water on infrastructure and on the natural environment. And we'll talk about that in a second. Two more, and then I'm almost done. But I can't not thank WPBT2 enough, one of our public television media partners for our grant. They're putting together with Professor McMillan what will be a fabulous half-an-hour program in either the spring or summer of next year. And I'm secretly trying to see if there are some students here who are interested in media production who might be able to take like 30 seconds of B-roll and have that air on public television. And lastly, I'd like to thank Miami Tees for helping us create these wonderful T-shirts. Yeah, they're nice, aren't they? I make curves look good, and so these T-shirts help. And so what these T-shirts are is for the 38, 40 students who'll be going on to Alton Road on October 9th, they'll all be wearing these T-shirts. And the purpose of that is not just to get out our great design that was actually created by a recent graduate of the School of Journalism and Mass Communication, Natalie Marola, and we want to thank Natalie for that, but also to promote our website. Right? The eyes, that was nice, right? I practiced that. So eyesontherise.org is a website that this project is revolving around. And we want you all to contribute to it. We want you to learn from it. We want you to be teaching people about the environment down here in Miami. This is a special place. Right? This is an important place. And we have to do the things to save it, right? To keep it safe and clean. Because we have lots of future generations who need to benefit from this wonderful part of the world. So without further ado, I want to just introduce Caroline Lewis with the Clio Institute. And Caroline's going to give us an overview of climate change. But you guys are experts, right? So this is really for the people who are watching the live streaming because you guys are already experts on this. But she is even more of an expert than you are. So she's going to try and teach us some things, and then I'll come back and we'll do a couple more conversations before we end for the day. Okay, Caroline?
Thank you. Thank you. Can you hear me? I like to be close to students. I was a school teacher, a school principal for 22 years, and I am just so delighted to be here. I don't know if you practiced, but you look extremely engrossed. So I would like you to continue to look engrossed even if we bore you to death. You have excellent faces, and more importantly, you have incredible roles to play. My name is Caroline Lewis. I was born and raised in Port of Spain, Trinidad, a little Caribbean island. Not Jamaica, no. They're the reggae dancers. We are the calypso dancers down in Trinidad. But what I want to... Ted, is that good enough? Good things come in small packages, Ted.
Wait, what are you saying?
I'm saying I'm short, but I'm adorable. There you go. There. All right. No, it's good. No, I got to double mic it. So, all right, students, listen up. Having been a school teacher and a school principal, one of my biggest challenges is to make sure that every single one of you in here understands that I believe in you, that we need your generation, we need your voices, we need your passion to take on some of the stuff that we did unintentionally and now intentionally. We need your passion and we need the fire in your belly that you're developing. But we do not want your passion if it is not steeped in information. So you have to steep yourself in the current science, the data, the explanations. Part of the role of the Clio Institute here today is to make sure that you can connect the dots between sea level rise and carbon pollution. We're going to be partaking with FIU scientists and FIU students in some serious scientific measurements on October 9th. I do not want those measurements of a high tide on Miami Beach to be a shot in the pan experience for you. I want you to know that when you see high tide, when you see a sunny day and the streets are flooding with salt water, that you understand that we're causing that to happen. We're causing the sea level to rise because of carbon pollution. And if the two of you need help, let me know. I warned you I'm a school teacher and a school principal. When you're speaking, I will listen. And when I speak, you have two choices: listen or pretend to listen. That's it. It's so important that this little girl from Trinidad has given up six-figure jobs to work in a nonprofit in order to bridge the divide between science and society on climate change. When we formed the Clio Institute, we were talking about studying food, energy, water, and bridging the divide between science and society on those issues. The climate scientists in Miami got a hold of us, grabbed us by the scruff of our necks and said, help. The science is so urgent and so daunting that we need help getting the public to understand it so we can make some changes. So Clio became known for its name, Climate Leadership Engagement Opportunities, instead of just creative learning. We believe in helping people become learners at any age. So we worked with everybody, from K to Gray. We work with elected officials, business leaders, community leaders, kids, teachers, professors, all the colleges, and I tell you, FIU has been a most impressive partner, especially the School of Journalism and Mass Communications up here. Thank you so much for being our partner on this. We're blown away impressed with your work. So what I want you to do for me is to make sure that you think about this. About 35 of you are going to come back right after lunch and work with the Clio staff. I'm so pleased to have Marissa Prieto and Karina Castillo here with me. They have done a lot of work in getting ready for this. And we're going to work with you, 35 students, to make sure that you understand the connection between carbon pollution and sea level rise, and that if you are interviewed on October 9th when we're out there doing field work, that you can make that connection and not just sound like a one-time experience with salt water at your ankles or shins. So the goal for the Clio Institute is to bridge that divide. We work all over Florida and we work in DC. Most of our friends and the scientists we work with write professional papers. Have you heard of the IPCC reports? Raise your hands if you have. Have you heard of the National Climate Assessment reports? Raise your hands. All right, students, I want you all to know this. Look at the bottom right picture. It's a little old-fashioned, this slide up here, but in the bottom right, it's just about any street corner in Miami, right? When you look at that, do you ever think it once looked like that top left picture? We need to really think about the carbon footprint, the human footprint. The IPCC reports and the NCA reports are international and national studies by our best climate scientists who've been studying, measuring, and accounting for every bit of atmospheric change that has been happening. And what we have found is that the rate at which carbon dioxide and other greenhouse gases is entering the atmosphere is causing the Earth to warm much too quickly. And as a result of that warming Earth, we have a series of climate disruptions, one of which is sea level rise. Keep that in mind. The rate at which we're pumping carbon dioxide is warming the Earth and causing lots of climate disruptions, one of which is sea level rise. Another one is heat. Another one is health. Mosquitoes can now live in areas they never used to be able to live. Vectors, invasive species, they're moving up in the latitude. Biodiversity is being disrupted. This has become so severe that the IPCC authors, the international scientists, and the National Climate Assessment authors, when they write, they are writing with more and more urgency, begging the world to pay attention. Last Sunday in New York City, 400,000 people took to the streets of New York to demonstrate that we need action on climate. I can't look at you in your face and tell you I'm leaving you a world that's warmer and more threatening than a world I enjoyed. I have to fight to undo the damage we have done. And so our cause is to support the scientists that are finding out these things and are trying to tell us it's very, very serious. I was at the march in New York. About 17 of us from Clio Institute went up for that march. It was so heartening because I need to know 400,000 people know what I know. I want you, mass students, to know what I know, that there is a connection between sea level rise and carbon pollution. I want you to know Miami is not alone. 53% of the U.S. population lives at or near the coast. We're all vulnerable. This is what the pictures look like. When Hurricane Sandy was moving up the coast, it just sideswiped Fort Lauderdale. What you see there with the little tractors on is the street. That's the evacuation route. That's A1A. We had to build that back after the hurricane went by. They didn't build it back the way it was. They built it back to a new normal, higher, more resilient. When you look at Miami houses that are not on the coast, in high tide, when that water has nowhere to go but up through the drains, this is what happens. Look at another one. You see this house? You see the storm drain there in the front? That is to take away rainwater when we flood. Well, sea level is rising so rapidly and coming in that instead of draining water, we're bringing water in. Look at what happens at high tide. Now, I'm hoping you're connecting this to carbon pollution, right? Don't just connect this to sea level rise because it's sea level rise. One more. Do you see the drain? Right? High tide. Now that guy thought he's have waterfront property now. That is salt water, friends. That is not fresh water. That is ocean water coming in. Now look at this slide. This is why it's happening. As the sea level rises, and the next two speakers after me will explain a great deal about sea level rise. But as the sea level rises, it encroaches, it brings the coast in, and our fresh water is compromised. And the salt water is part of where we are. Oh, by the way, I leave these slides with you so you can have them and share them with the students. This is my slide, my appeal to you. If you or your family or friends do not want to talk about climate change and carbon pollution and sea level rise, beg them. Every single one of us has a role to play. And you might think at 15 or 16 years old, what on earth is my role? Trust me, you have a role. Each one of us needs to understand how we live, how we spend our money, how we vote as soon as we're eligible to vote. Makes a big difference. The world really is in our hands. And so today I'm going to ask you to do something with me. I want you on a scale of 1 to 10, right now. Grade yourself on your understanding of the science of climate change, about your understanding of fossil fuels burning and carbon dioxide and methane and other gases going up, of your understanding of ice melt and everything else. On a scale of 1 to 10, 1 being, I know very little. I know people like Mrs. Lewis up here is worried, but I don't really understand it. And 10 being, I know everything. I'm a published author for the IPCC reports and for the National Climate Assessment reports. I am brilliant. I study atmosphere, ocean, and everything in between. So on a scale of 1 to 10, in your mind right now, give yourself a score. Turn to the person next to you and share your score. All right. Thank you. Do we have any 9s? We got a 9? We got a 7. 7. Who are these experts? Will anyone who scored themselves a 7 or higher please stand? Have a seat. Thank you. I am really amazed because I'm a 6.5. And I tell you why. I know how much I don't know. I play with the scientists. I operate in the DC level, at the National Climate Assessment level, at the IPC level. I speak to these people. And I gave myself a 6.5 because I know how much more I have to know. So I'm really proud of you, and I hope you're part of the 35 I get to see, because I need to see if you're really a 7. And if you are, I'm going to be carrying you on my shoulders on October 9th to make sure the press interviews you. Because I want to make sure if the press interviews you on October 9th, you are coherent, you are accurate, you are logical, you are hopeful, you're solution-oriented. So that's what the training after this is about, to make sure you're all of those things. I'm going to ask you to do one more thing in terms of rating yourselves on a scale of 1 to 10. On your level of engagement, talking about climate change, discussing it with your peers and your family, living as small as possible without compromising a style of life. Would you rate yourself a 1, meaning I do nothing, leave me alone, I am an island, it shouldn't matter, go away? 10, a 10 would be someone who does not shut up about climate change and carbon pollution, whose family is so sick of them, they won't even have them over for Thanksgiving anymore. So, in terms of your students, we have people listening. They're trying to rate themselves too. Be quiet. So, 1 meaning, leave me alone, I'm an island. 10 meaning, I have no friends. They won't even have me over anymore. I don't shut up about it. I'm an 11, just so you know. But what are you? Tell the person next to you what you gave yourself. What are you? Are you really? What are you?
Yeah, I'm 3. 4.
Okay. Thank you. The idea is this. For us to be climate literate, and to take action on climate change, we have to acknowledge we're all works in progress. We're all at different places. But own this. We're on a journey, each of us. And I hope today, like me, you take your next step up on that scale towards being climate literate and fully engaged on solutions to combat this problem. I look forward to working with you. I can't wait to see who the 35 of you are. And I look forward to October 9th when the press is just blown away by the FIU students here at this campus. Thank you. And now it is my pleasure to introduce two of the best teachers I ever met. I just met them. They are two of the most handsome, young, bright teachers you will meet. Round of applause for your own peers, Saad, and Noe. You know how the clicker works, right?
Oh, yeah.
No, you want to take that soda, or should I take this soda?
That's it. Good morning, ladies and gentlemen, and fellow students. As you may know me, my name is Noe, for those of you who don't. And this is my fellow classmate.
And my name is Saad Masood, and here we represent the sophomore class at Masted FIU, as you already know too. Here to present to you. And we're here to present to you about sea level rise in South Florida.
Hopefully we don't bore you that much. I'm hoping. All right, so we start off with a cartoon, an icebreaker. It's your classic Peanuts cartoon. It says, "Hey, Charlie Brown, I found a bottle of fresh water today. How about you?" And Linus said that, but Charlie Brown said, "I got a rock." Linus responds, "Say, have you checked with that dog of yours?" And he says, "He's been saying that for years. Why don't we wait over there and check?" Later on, he sees that Snoopy's drowned already. Long gone.
Good grief. So, in actuality, the real question is, what exactly is climate change, and what exactly is sea level rise, and what does it entail here in South Florida and its immediate dangers and consequences to all of us who live here? Basically, sea level is defined as the increase in water levels due to thermal expansion and the melting of land ice sheets such as those found in the Arctic and polar regions.
This is actually a small diagram of what you could say is a coastal area. We could say it's Miami Beach, but really Miami Beach, the height that the land is on, it's really small. It's not so much to this area pretty much. And as we all know, Florida's main water supply is its aquifers. Its aquifers is where all your fresh water, your drinking water, the water you shower in, the water you use to clean your dishes, that's all from Florida's freshwater aquifers. And as sea level rises, that causes pressure to build up on the aquifers. And since Florida's limestone rock is really porous, that causes brackish water to form, which is, for those of you who are in apes, that's saltwater intrusion. And for some locations in Florida have wells, and these wells, they mostly lead to aquifers. When you have brackish water, therefore all your water turns into salt water.
And for those of you who may not be familiar with what thermal expansion is exactly, in its most basic definition, thermal expansion is defined as matter changing in volume with differences in temperature. So as we see global warming take effect, we're going to have water and sea level beginning to expand due to increasing temperatures, and as it expands in volume, we're going to have rising levels naturally.
So sadly, Florida only really relies on two ways to prevent floods. One of them would be extensive and elaborate diverted canal systems throughout the whole. This mostly focuses on the Broward County area and Pembroke Pines and Miramar, not so much in downtown Miami and South Beach. There's actually 1,800 miles of canal systems throughout the whole throughout the whole county of Broward County. And the sewage and drainage system, that's mostly down south. That's mostly Miami Beach area, downtown Miami, and actually the area FIU is on relies on sewage drainage systems.
And here we also brought to you another diagram showcasing how we generally get rid of waste here in South Florida. We have, as you can see, we have stormwater being released by clouds as well as residential water, wastewater from your homes. And we have business wastewater released by factories and tall buildings. And they all lead to the same drainage system, which, after undergoing primary sewage treatment, is eventually dumped back into the ocean in a process which is pretty self-explanatory called ocean dumping.
We believe this is it's a pretty disgusting way of disposing of water, since we all know, when you drive on the street and you drive through parking lots, you see cars often leave engine oil dripped on the street, or you often have your animal manure all over the ground. And when there's floods, it pretty much washes everything out, and it basically goes down into your flood, and only a small percent, you could say at least 75% of it all leads to the ocean and doesn't get actually treated. So it's basically like swimming in your own toilet bowl when you go to the ocean at times. Actually, it happened, I think it was over the summer that the Sunny Isles area actually had, the beaches were all contaminated with fecal coliform, and basically the beach was empty for a good month. So this is the reason why we'd say canal systems won't work in like the Broward County area when sea level rises. You see, canal systems, they work by acting on gravity. The canal containment water zone always will be the level of it would always be higher than the ocean level. And once sea level rises, it basically, the water is all at the same level, so it can't really fall into anywhere. And since we all know Florida's limestone rock, which is mainly all the rock under you, it's really poor, so it just seep right through into your home.
Have you ever seen these types of pictures? You may be driving with, your parents might be driving you someplace, and you wonder, it hasn't rained yet there are still puddles on the side of the street. Well, in actuality, if you haven't realized, this water is actually found when drainage systems eventually regurgitate or release water right back from their drainage systems, and it comes to the surface.
This is actually a picture of after a massive rain in, I think that's the Aventura area, if I'm correct. You would think after a huge rain, you would think some of the water, all the water is going to go down the sewage drain, because that's what Miami mainly relies on to clean out floods and pump it all back into the ocean. But really all the water, since the sewage drain is already backed up, most of this water would mostly be evaporated. Part of it, a good part of it would be evaporated back into the atmosphere. And this is the reason why sometimes right after a huge rain and you see all the water's already cleaned up, you'll often see trash in the middle of the street, and you would think, wait a second, this trash, if it flows down to the sewage systems, it'll all lead down to right below the sewer, and all the water bottles and all the trash on the street would be collected there, but it's actually in the middle of the road, and which is pretty disgusting if you ask me.
And with sea level rise and global warming, you're going to see several different effects, especially in coastal areas as in Florida. First of all, we see saltwater intrusion. As pressure begins to rise, we have saltwater pushing its way through our porous limestone and eventually contaminating our water supply, leaving thousands of people without water. We have property loss as $145 billion worth of Floridian property lies less than 3 feet above the high tide line, and as sea levels continue to rise, it's eventually going to corrode and destroy what property we have on that line. And as that continues to happen, people are going to be displaced from their homes. They're going to have to move away, or they're going to have to refurnish and renovate all these different areas. And increased ocean acidity with carbon dioxide and water is going to eventually create carbonic acid, and that's going to destroy coastal ecosystems such as mangrove ecosystems or coral reefs as a result of ocean acidity, which provide nurseries for different organisms and habitats for others.
Okay, we have a timeline for you on, basically it's an outlook of how Florida would end up. Okay, so as you slowly see, with just 1 meter of sea level rise, you already see the whole Everglades area already flooded. With just 2, you pretty much have Miami, the whole Miami-Dade County underwater. After 3, you could forget about South Florida pretty much. And so on after that, it just, all of Florida is pretty much flooded.
After about 3 meters, you see that almost half of the population is completely effective, which is going to have to make them either migrate north or swim.
How's it going? There you go.
Next slide.
Is it working? Yeah, it's right there.
Oh, okay, you want me to click it?
Yeah.
Or I think you're going to click it.
Apparently the clicker's not working.
And then here we took the liberty to show you the loss percentages based on, we have the different counties here and the different amenities and reservations that we have. If you look here at Miami-Dade, with just 3 feet lying above the high tide line, we have 25% of the land that is expected to be effective. A full quarter of all the land that we have in Miami-Dade County, as compared to Monroe, which houses the Everglades, and we have 74%, so that's pretty much gone. And then property value, 11%, 42, and that's going to destroy homes and population, 7%, 5. And then we're going to eventually come down to power plants, as you can see in Miami-Dade, which is a full 17%. Can you imagine paying either more for your electrical bill or just not getting it at all?
Okay, and here's we have a chart with the vulnerability of different cities in South Miami. As you can see, with just 3 feet of sea level rise, already over a little bit less than 500,000 of people would be displaced from their homes already. As you can see, in this location, you see Miami Beach. It goes from most to least affected. Miami Beach is mostly in all of number 1 in all of them. For property value, as Saad said before, you already have $145 billion of property value lost already. Housing units, you have 300,000, a little bit more than that, already gone underwater. And if you really think about it, what is Disney to Orlando is the beach to Miami. When you don't have that, if you really think about it, what would Orlando look like if there was no Disney World? Probably be an empty city, pretty much, a ghost town. So what would happen if you took away the beaches from Miami? Miami would pretty much lose all their economic income, and therefore you have a ghost town, pretty much, underwater.
And we thought we'd just explain to you the different basics concerning tides. Tides are defined as the rising and falling of seawater, of water levels, due to the forces exerted by the moon and the sun. But that's not it. There are 3 different types of tidal patterns. We have diurnal tides, which is 1 high and low tide per day, semi-diurnal, which is 2 high and 2 low tides per day, which are similar in height. But then we also have the third kind, which are mixed, 2 high and 2 low tides per day, but they're different in height, which makes it harder to predict their effects.
We also have 2 other different types of tide. We have spring tides, which is when the tides are the strongest, which is, in this case, when you'd probably see Mr. Roach surfing through at the beach. We have neap tides, which is when the water is completely calm and there's no waves whatsoever. Here is a small GIF media file for you, kind of explaining. As you can see, spring tides only happen when the sun and the moon are perfectly aligned. Neap tides, in this case, would occur when there's pretty much a 90-degree angle between the sun and the earth and the moon. Go. I keep on forgetting.
And then what we're going to be studying on October 9th is referred to as the King's Tide. What people generally think of this as is a spring tide, but that's not exactly true. This type of tide is far more damaging as water levels continue to rise 2 feet above the high tide line. And if you think about it, 3 feet is where $145 billion worth of property value lies. And this event generally occurs late September, early October, and we're going to be specifically studying it on October 9th. We also took a bit of a historical analysis. Currently, it's estimated that a flood with a 1% annual chance, what we call an extreme flood, is going to happen, is going to increase by about 10% annually with a chance of occurrence in just about a couple of decades, maybe about 2050. Interestingly, this statistic since 1913 has been exceeded only once in Key West, one of our lowest lying coastal areas. So you can only imagine what it can do in areas like Miami Beach and such.
Okay, so as we look over the past 2,000 years, we see that sea level rise has always had an uneven increase. It was steady for the first 900 years, and then after it hit the 1900s, it pretty much created a domino effect. With the 1900s, you see the Industrial Revolution come in. We see globalization, and we see an increase in population, increase in cars on the street. We see an increase in factories around the world, which therefore increase the carbon emissions, all the carbon emissions go up into the atmosphere, they deplete the ozone layer, cause global warming to increase, and thermal expansion to occur, which therefore causes sea level to rise.
It's a long process.
As you can see here, this is a chart of pretty much from 1960 to around 2005 of how much sea level has rose. As you can see, from the year 1955 and until the year 2005, it has gone up about 25 millimeters around there. And we could only imagine, I mean, this part, the middle, you could say, I guess, from 1955 until 1990, it's kind of steady and slow but steady. But as you get to the year 2000, around here, you start to see it start to take on an exponential growth. And you could only imagine the years after that, how much it would grow more.
Because it's only been since 1990, as populations grow and more factories are added, that you see a much larger increase in carbon emissions, which is already resulting in the slope of this graph to exponentially rise, and it's going to eventually cause a much larger effect on sea level as well. Statistics and probability. Currently, 2,120 square miles of land lie less than 3 feet above the high tide line, which equates already to $145 billion and 3,000 homes. And if we look at those, and we look at that statistic, that amounts to approximately, 10,000 to 1 million people. Since the 1900s, we've had 8 inches of global sea level rise. But since 1900, we've also had more and more people being added to our Earth, and we've had several more factories, which is going to result in an increase in carbon emissions, a larger carbon footprint, and therefore an increase in global warming as well. According to Surging Seas, a local research paper dedicated towards finding more information about sea level rise, we can expect to see 1.6 feet, 3.3 feet, or 4.9 feet of sea level rise by 2100, if we look at only 1992 as a starting point for this. There are exactly no solutions to sea level rise as much as there are ways to decrease its effects. What you can easily do is inform those who contribute to global climate change, such as those large factories who are continuing to increase their carbon emissions by releasing methane, tropospheric ozone, hydrofluorocarbons, and black carbons. You could reduce the amount of fracking or fracturing, motor exhaust, chemical solvents, and industrial emissions.
Okay, so what Saad just talked about was really on an industrial level, something industries and large companies can do. But something little you can do, as little as in your own home or when you're out on the street. You can reduce water usage. You could take shorter showers. Believe it or not, you save tons of gallons by just cutting your shower short by 2 minutes. You could use gray water. You could use water-efficient toilets. Believe it or not, Home Depot actually sells those. You could drive less and drive smart. Fuel-efficient cars are actually much cheaper and they waste much less gas. And use public transportation. The public bus is always going to go around the city. If you get on it or you get off it, doesn't really matter. It's still going to waste the same energy. You can reduce, reuse, recycle. There's actually a really good video we already watched it for those in AP Human Geography, actually AP Environmental Science, called The Story of Stuff. It kind of goes into that. You could use the off switch, turn off the lights. If you're not using it, it always helps. Change a light bulb, LED, compact fluorescent light bulbs, which in the long run, they save you a lot of cash. You can shop smart. Again, if you think about it, when you go to, let's say, Target, and you buy, I don't know, a radio,
$4.99 radio.
you probably, that radio, you always have to think of the carbon footprint that radio has created. Probably the plastic from that radio was probably mined in Africa. The metal in it was probably from Indonesia, assembled in China, transported to the U.S., distributed from one central city. So yeah, think about, before you buy stuff, pretty much think about where it came from. You could also shop smart. Less packaging, the better it is. This is pretty much a web of basically what I just said, plus a few things more. As you can see, up here you have the traveling. Over here you see little things you could do at your house. Up here you could see what you can do with the government, pretty much. You could vote for healthier recycling, all that, and when you go shopping.
And then there's always been an age-old argument whether or not global warming exists, but whether you're on one side or the other, it really doesn't matter because it's happening either way. By the time you're done arguing, we're already going to be submerged underwater. As you can see, it's rising due to global warming or it's rising due to natural causes. It doesn't matter in the long run. There are for and against topics concerning global warming, such as the fact that humans are too insignificant to affect global climate. Well, that's not at all true, because the more humans we have means the more output that we need. So factories continue to release more and more carbon emissions, which is going to destroy the ozone layer, which in effect is going to increase global warming. There's no tropospheric hotspot, you say? Not true either. It has been known that there is short-term hotspots, and therefore evidence would suggest that there are long-term hotspots too. And then there are some that might say sea level rise is decelerating. But then that's only if you look at a standpoint where there's one tiny blip in the chart or the graph, but that may have just been a fortunate year. Sea level rise has been increasing nonstop since 1880, and future predictions are based on physics, not statistics.
It's basically our bibliography, and
This concludes our presentation.
This concludes.
Thank you.
the clicker doesn't work.
Oh,
It just stopped in the middle of the
Would you mind
presentation.
if I just introduce you?
Sure.
But
Why does this not work?
we would just like to next introduce Dr. Susan Jacobson, who will be discussing more in depth about the King's Tide event that will be taking place on October 9th. So give her a cheer.
Thank you. How do I make it go? 'Cause it
Yeah,
doesn't
no.
seem to be working.
I just frequently rose
Oh, there we
wasn't
go.
known, yeah.
Okay. All right. Thank you so much, and thank you, Saad and Noe, for that really inspirational presentation. I learned a lot, and I have been learning a lot about sea level rise. Thank you. Can you hear me now? Okay. And I have been studying a lot about sea level rise. As part of our grant application, as part of the project that we've been working on here at FIU, we're working with Code for Miami, Hacks Hackers, and the FIU GIS department to develop an application to help inform citizens in South Florida about sea level rise. Part of that app is, it's currently under development, but part of the app is dedicated to sort of showing what your address might look at different levels of sea level rise. And a big part of it is about reporting flooding. As it turns out, flooding is underreported here in South Florida. I'm one of those people who live near Aventura, and when it rains, it floods. My whole neighborhood floods, and this is unreported. So one of the things that we're developing is a tool to help citizens report flooding. So we can map it, and then we can have it available as a database. So if you live somewhere, you can kind of see where the flooding is taking place. And what we have for October 9th, which I'm going to talk a little bit about some of our activities on that day. But one of the things we are going to ask you to do is when you are out on Alton Road, or if you're not on Alton Road, but if you are elsewhere in Miami, in Miami-Dade County, and you see some flooding, if you could use our flooding report tool to just tell us who you are, where you were, what you saw, and you can upload a picture of or a video of a flood that you saw. Right now it's at a URL. It's at eyesontherise.org/flood, so it's very easy to remember. But if you can help us with that, we would greatly appreciate it. Okay. No, I'm trying to do that. So October 9th. On October 9th, a group of you will come down to Miami Beach, where we will all go out onto Alton Road. Who's been out in Alton Road before? Okay, very good. So October 9th is the day of the king tide, the highest high tide of the year. So we anticipate that there will be some extra flooding on the streets. Now, some of this may be mitigated by the new pump system that the city of Miami Beach has installed. This is something that both we and they are going to investigate. So some of you will be going out with sensors to measure water quality. Some of you will be able maybe to document any instances of flooding that you see along Alton Road, and we will have several places where you can go look. At the same time that you all are out on Alton Road, the Alta balloon, Alta is a company that we work with here at FIU. They specialize in high-resolution images captured by balloons, and they're going to be able to show us how the high tide is affecting the coastline. Another group of FIU students is going out with the hydrology department on a boat to also monitor water quality. So we're very excited about this activity taking place on October 9th, and we're very happy to have your participation. And so now I'm going to ask Dr. Gucci to introduce Lily Bui from the Massachusetts Institute of Technology, who's going to talk to us about sensor journalism.
Okay, are there any nerds in here? Any geeks? Okay, so this is going to be the fun part. So Lily is a graduate student at MIT, and okay, you can put your. Lily is a graduate student at MIT, and she's going to talk to us about these really cool sensors that we're going to be taking down onto Miami Beach. But also, she's going to talk about how we can use sensors to do journalism. And so, right now, I'm going to figure out how to do Skype and PowerPoint at the same time. Lily.
Hello.
Thank you for joining us.
Thank you for having me. I can't see the audience, but you guys sound young, and that makes me feel old. But and I heard that there's some geeks in the audience, so I feel like I'm talking to my people. That's awesome.
That's great.
Should I introduce myself, or did you want to introduce me?
You go ahead. You have the floor, and I'm just going to stick around and make sure that your slides show up okay.
Sweet. Okay. So you're going to see my face for a little bit, but I'm going to go to the slides. And so I am a grad student at MIT, and I'm looking into this new space called sensor journalism, and we're calling it that, but it doesn't necessarily exist as a practice with, you know, a framework just yet. So I want to talk to you guys about it and kind of contextualize how the work that you guys are going to be doing with the co-key sensors and all the efforts that are happening around King Tide Day kind of tie into this field. So let me figure out how to get my slides up on the screen. Share screen. Can you guys see them? Sweet. Aw, I love how participatory you guys are. This is awesome. Okay, so let's go to this slide. And we're going to talk about two words in sensor journalism that are very, very important to define before we do anything else. And so I wonder if I can hear you. Like, who has an idea of what a sensor is or could be? Just shout it out. Yeah, that didn't work. I can't really hear you guys.
So hold on, Lily. Let's see. Somebody. What's the question? What's the question, Lily?
Oh, the question was, what do you guys think a sensor is?
Oh, what's a sensor? Okay, just tell us. They don't want to participate. Oh, hold on.
Okay. I tried.
This
I
guy,
tried.
hold on.
A sensor is something that picks up information.
Something that
Picks up information.
picks up information. Great. Yeah, that's a great place to start. So a sensor is something that will pick up information, it logs data, and also an important thing to remember is that it reacts predictably to the environment. So it's a tool that you can use that you know is calibrated a certain way, that it will tell you something about the environment that it's measuring. And then the other really important term to define is journalism. And you will find as you go that journalism is something that is very undefined at the moment because of how things are changing. Traditionally, journalism really happened in newspapers, on TV, and on radio. But now with the advent of the internet, blogging, social media, and a bunch of other different forms of creating content, the definition of journalism itself is rapidly changing. So I want you guys to think about that while I'm doing this talk. So when you mush these two terms together, you get sensor journalism. And the way that I've been talking about it is that it's the idea of using sensor tools to generate or collect data, and then using that data to tell a story. And I'm so impressed by the presentations that you guys have been giving. I'm learning so much about how you guys are approaching this, and the fact that you understand that data can be manipulated in such a way that it doesn't really give you the full picture. So you guys are already aware of that, and that is awesome. So in talking about sensors, you are probably already familiar with what sensors are because they're around us every single day. And you'll see in these slides that there are a bunch of different kinds of sensors that you're probably able to recognize. There's the Fitbit, the Jawbone that track your health. And there are satellites that orbit the Earth and take measurements and photographs of weather and a bunch of other types of data. And there's this iWatch that just came out with a bunch of different sensor tools, and then there are security cameras that can also be considered sensors because it's reacting to the environment and recording information about it. And you can probably find a bunch more that you can list, and I encourage you to think about where sensors might be in your everyday kinds of experiences because it is becoming more and more of a thing. And so the things that sensors can measure are directly related to the things that they can help investigate when it comes to journalism. So if you think about stuff like air quality, water quality, which is what you guys are working with, pollution, public health, things like deforestation and noise pollution even, there are sensors that can help track things that relate to these issues. And one important parallel that I like to draw between journalism and science, I don't know what your guys' backgrounds are, but if you've had any exposure to either of these fields, you'll know that most of the time, the process starts with a question. So you have a question about the world around you, and then the goal is to go out and collect information about it, report on it, analyze it, and hopefully be able to replicate it. But the important part for journalism is really being able to communicate what you find to the public. But the implications of what you find are really important to think about because you want to make sure your data are as accurate as possible so that you don't convey the wrong information. And so in thinking about the history of censored journalism, there's one example that I like to point out a lot. In 2008, China hosted the Summer Olympics. And years before that, when they were still planning this event, the board that was in charge said, look, China, you got to up your air quality standards if you're going to bring all these people to Beijing, because right now your air quality sucks. So to keep Beijing accountable for having done this, the Associated Press, which is what AP stands for in this slide, equipped a bunch of their journalists with this TSI sensor, and this is what it looks like. So a bunch of journalists showed up in Beijing, and while they were reporting on the Olympics themselves, they went around the city and took these sensors to measure air quality to see if it was meeting World Health Organization standards. And this is a great example of how sensor journalism can work. So this is something that I've been working on in my own research, and so Ted was really excited that I could teach you guys the word typology, but you guys are so smart you already probably know it. But for the purposes of the presentation, a typology refers to a classification of something. So there are a lot of different sensor journalism projects out there right now, and I've kind of put them in categories to help you guys think about them in different ways. So that's why it's called a working typology. It's still in progress. It's not to say that it actually works just yet. I think time will tell. But so the first type of project that I want to talk about is where journalists are using the sensors. So you would train someone in a newsroom or a small group of people in a newsroom to use a sensor tool. An example of that would be equipping a newsroom or a journalist with a drone And drone technology is a little bit controversial. If you guys are interested in learning more about the policy implications around this, feel free to email me or tweet at me or just yell after the presentation is over. But so, like, you can technically take a drone and fly it over crowds or any kind of area and record information about it in the form of photography, video, or any other type of sensor, like including infrared. And this is controversial because it kind of infringes on privacy in a lot of ways, but it is an example of how you can use a sensor for news reporting. Or there are other open source tools that you guys are actually going to be working with. The Coqui is an example, and then you guys, I heard, are doing balloon mapping. This is another example of how you can bypass all the legal restrictions that are currently on drones. So a balloon mapping kit is tethered to a rope, and you can also fly it up high and take aerial photography with it, and then use that data or those photos to report on. The other kind of project is putting sensors in people's hands. So this is where a news outlet will report on a story and then say, hey, readers or audience members, here's this sensor. We want you to go collect data and help verify this other data set that we're looking at. We want to see if this still holds true or if there's something else that we need to be looking at. So one example of this, which is awesome, is WNYC's Cicada Radio Tracker. So WNYC is a station in New York, and what they did was create an Arduino-based sensor that records soil temperature. And their basic question was, will the cicadas emerge when the temperature increases? And so the data news team put this sensor out there. They put the design online and said, you can buy these parts, they're super cheap, go build it at home, and then tell us what you find. So on their website, they put this data app on there, and it's on the bottom right of my slide. And you'll see these green dots, and those correspond to the lights on your sensor, and you would just click on the ones that you saw that were on, and it would output whatever temperature that corresponded to. So a bunch of people participated. All those little orange dots are different data points. And so as people were reporting in their data, the news team at WNYC was mapping all this data on CartoDB, and they were also blogging about the process. And lo and behold, yes, cicadas emerged and were spotted more frequently as the temperature rose. And it's a really simple experiment, but it's this really awesome, cool model where you open up the newsroom, and it's no longer a one-way relationship where you are given all this information and then that's the end. It's more like you're given this information, what can you do about it, and how can we help report on what you do about it? So it closes this interesting feedback loop that didn't really exist before without the internet. Another type of project is using existing sensor networks. So like I said before, there are sensors all around us, and there are sensor networks all around us. So a bunch of sensors measuring the same thing, but they're connected to each other. That's a way to think about it. So Christchurch is a city in New Zealand that suffered a gigantic earthquake and which destroyed most of it a few years back. And in rebuilding the city, they're actually thinking of equipping it with a bunch of sensors. And they're trying to measure everything, which is amazing. And I'm not really even sure how it's going to play out, but they're dreaming big when it comes to sensors. So for example, I talked to the guy who runs this, and so they have these inhalers where, like, when you use your inhaler, a green LED lights up, and your inhaler sends a signal to a satellite and then a computer server that tells whoever is managing this data that you are using it, and then it compares it with air quality data. So it's a study on how air quality affects inhaler use, and that's just one of the things that they're looking at. But they have really strong core principles. So one, the data is open. So this data isn't going to be used without you knowing it, and you have access to your own data, and it's all public. The second thing is that they'll never track individuals. There's nothing that will personally identify you. And if you guys ever start talking about data privacy issues, this is going to come out more and more. The fact that data streams are more ubiquitous, as in they're everywhere now, and we have all these devices that are constantly sending data out. But the fact that they can track you with it could be a dangerous thing. And so this project is keeping that in mind, very much so. And number three, like I mentioned, they're trying to measure as many things as possible. Mobile sensing is another really great thing that people are trying. And this is a graph of all the different sensors that exist in your smartphone. This is only for Android. And so you'll see that the next generation of Android phones is going to include barometric pressure. And that is really important when you're thinking about stuff like weather and climate change. So there's a lot of potential to move into this space and use sensor data for storytelling and journalism. So I want to point out a couple examples of mobile sensing. In Massachusetts, there's this app that you can download. It's called Street Bump, and it uses the accelerometer data in your smartphone, which really tells your phone how it's moving and what position it's in, and like whether you're turning it or dropping it or whether it's high, low, whatever. But you turn it on when you're biking or when you're driving, and the accelerometer data logs how bumpy your ride is. And using that graph and using that data, the city can kind of get an insight of where the potholes in the street might be, and that helps city planners understand where there could be more improvement. But so the caveat to this, or like the downside to this, is that yes, it's a great idea, but I went to the Street Bump website, and although people have been using it, it looks like there's 549 trips and like almost 40,000 bumps, but no potholes have been filled and no problems have actually been officially identified. So it's a great concept, but there's a lot of other stakeholders that really need to step up in order for it to be effective. So reporting on it is one thing, but really getting all the policymakers and all the people who can make these decisions and take action on the data is really important as well. Another type of sensor journalism project can be around remote sensing, and this is sensing at a distance. And the best example that I can give you is satellite imagery. So satellites orbit Earth every day and report back on a bunch of different kinds of data, but the most public data sets usually have to do with weather. And so my friend Julia, who lives in New Orleans, runs this thing called I See Change, and she asks people to submit their observations about weather, and so you can do that in the form of a photo, a video, or a tweet. And this is supposed to function kind of like an almanac to help predict future weather patterns or look back on past weather patterns. And the next phase of it is going to involve remote sensing data. They're partnering with NASA to get satellite data streams about weather, and they're also partnering with this group called Beacon in Oakland, which reports on air quality. So they're combining all these different data streams to help people better understand how weather is changing and then ultimately the effects of climate change. And then this has a question mark because it has a lot of different implications to it. It hasn't quite happened yet, but it is something that could happen but needs to be done responsibly. So you guys understand the concept of donation, right? You give something up, usually for free, to somebody else. And so if you think about this in terms of data, if anyone in the crowd has a wearable, you know that your Fitbit or whatever it's called will log data on your activity throughout the day. Now, what if there was a researcher who wanted to look into public health and any types of trends or fitness trends or exercise trends within a certain group or area? If people could eventually donate their data but have it be private and not traceable to them, this could be another type of sensor journalism, because a Fitbit is a sensor. You are generating data that is very personal to you, but it could potentially benefit other realms of research and storytelling. And so, like, when it comes to donating data, you need a place to put that data. And these are just a couple examples of different data repositories that are open source, meaning you have ownership over your own data, and that data is also shareable and viewable by the general public. And so these are kind of emerging trends, but it needs to be a space that is fleshed out a little bit more meaningfully before we can proceed. Okay, and so we've gotten to the very end. Thanks for bearing with me. This is a screenshot of the sensor that you guys are actually going to be working with. It's called the CoKey, and it is the conductivity circuit of the riffle sensor, which comes from Public Lab. And so the CoKey only measures conductivity in water, and conductivity is also it's a way to look at salinity levels. So the saltier water is, the higher the conductivity reading usually, and the reverse is also true. And so I'm really excited for you guys to build this. I don't know if they have actually arrived yet. Ted, did that happen? I hope so.
They're in boxes in my office.
Okay, sweet. So they're there, and so
in multiple pieces.
yes. So this is a really exciting time for you guys because you are going out and answering your own questions and you're doing it together, which is so indicative of this spirit of citizen science that I've kind of been a part of in different ways. And what's important to keep in mind is that you guys should not be intimidated by hardware, first of all, and that you guys are doing something that's part of a much bigger picture and a bigger trend that is emerging. And if you've never been exposed to open hardware before or any kind of hardware before, don't be scared. If you've ever put together a puzzle, that's pretty much the same process with this. You get pieces, you get instructions, and you can just figure it out on your own. It's not complicated. You don't need an engineering degree, you don't need a science degree to be able to do this. All you need is your curiosity, and that is a beautiful thing. And so I'm going to step on a soapbox for a little bit and say right now, the way that I've been looking at things, we're really good at creating news junkies. You probably heard people say this all the time, like, oh man, I'm such a news junkie, I love news. And you can get news in so many different ways, in your own inboxes, on Twitter, Facebook, BuzzFeed, if you want to call that news. But people would call that news, so like I won't be too critical. But so we're really great at gathering information, right? But what we need to be thinking about is how to act upon that information. And that's not to say that just because you have information, you are responsible for acting on it, but we should be thinking of different ways that people can actually feel like they have the opportunity to do so and investigate further if they want to, and work together with scientists and with newsrooms in order to do so. And so in thinking about the future of censored journalism, there are opportunities to increase awareness about our environment, as you know, with all you're doing with King Tide Day. There's an opportunity to engage the public in the scientific process. So most of you probably aren't scientists, but you're going to learn a lot about scientific thinking and the process of designing a science project or research initiative through working with this. It's an opportunity to shed light on local and global problems. As you know, climate change is not just happening in Florida, it's happening everywhere. Sea level rise is not just happening in Florida, it would happen everywhere. And lastly, it's an opportunity to democratize the data gathering and storytelling process. It's a more distributed way of doing things, which is a complete shift from the traditional model of journalism and science. But you don't have to take it from me. You can tell me your sense. Feel free to reach out anytime, and I welcome your questions, your criticisms, and your comments in general. And thank you so much for having me.
Thank you. Thank you, Lily. Thank you so
Thank you.
very much. I will leave you on if you want to hear. Dr. Welker is going to give us a few second goodbye, and then we can talk later.
Awesome. Thank you so much for having me again.
Thanks, Lily.
Have fun, guys.
Thanks.
Bye.
Bye-bye. Well, ladies and gentlemen, we are at the end of our presentation this morning. First and foremost, I want to thank you for your presence and your participation, and I want to give you a couple of takeaways. The first takeaway: sea level rise has been a component of the life history of our planet. It has risen and fallen throughout epochs. It's inevitable. It's going to happen again. It's not going to be biblical. It's not going to be epic. It's going to be initially like an episode. Whether it's King Tide Day or a nearby hurricane, we're going to see more and more frequent events of this kind. Mother Nature is relentless, and she makes no exceptions for ignorance or apathy. As young people, you will have to bear the burden of what the old people in this room have created. On behalf of them, I apologize. But there's a lot that you can do, individually and collectively, and you've heard a lot about it. From individual choice about what you buy, what you use, to a decision to be involved through crowd hydrology that we'll witness on October 9th, or to start and continue the conversation that began today. We cannot change the outcome. What we can change is the rate. Sea level will rise, that we know. How quickly is in our control. And we have probably the brightest, most talented, enthusiastic group of young people that I've had the privilege and pleasure of being around to work with daily. There is a solution, ladies and gentlemen, and the solution lies with you, who will help us to direct what will be the future outcome, not only for South Florida, but perhaps our planet. Unlike Noah, we can't escape this ark we call our planet. We have to correct it, we have to make change, and change begins with you and with us. Thank you very much, ladies and gentlemen. Mass teachers and mass students, I'm going to need your cooperation. We're going to exit quietly. We're going to start in the back rows and move out back to class. Teachers, if you'll assist, one row at a time.